One paper, November 2021, variant 51. Let's look at the first question. The first question says, two fair coins are thrown at the same time. The random variable x is the number of throws of the two coins required to obtain two tails at the same time. So now, based upon this info that I got, let's first work this out. When you are tossing two fair coins, there are four possibilities. Since it's a fair coin, head head, head tail, tail head, tail tail. All the probabilities are 1/4 each. So my focus is on getting two tails. So two tails is success, and this success, the probability is 1/4. Now it could be a question of binomial or geometric. Let's read further. The question further says, find the probability that two tails are obtained for the first time on the 7th row. This is the wording for geometric probability distribution, and part B also says the same thing. Find the probability it takes more than 9 throws to obtain two tails for the first time. So therefore, the working is this, that you write, first of all, x follows a geometric distribution with probability of success 1/4. On the 7th throw, so probability x is equals to 7, 1/4 will occur at the 7th time, 7th turn, and 3/4, which is failure, will be raised to power of 6. So that's the working for this one, as simple as this. And of course, multiply it out, 3 power 6, 4 power 7, simplify, write in the fraction form, that is 3,729 divided by 16384. Leave the answer as it is, it looks beautiful. Find the probability it takes more than 9 throws. So there is a rule which is very, very important. That is, probability x greater than n is q raised to power of n. All you have to do is to apply this rule. So probability x greater than 9 is 3/4 raised to power of 9. That is 3 raised to power of 9, which comes out to be 19683. And the denominator is 262144. So that is the working for this particular part. Now this is question number 1 all done. Question number 2. It says a summary of 40 values of x gave the following information, such and such. So I'm seeing the coding question after a long time. It's called coding, it's called assume mean. And what do we need over here? We need whatever is in the bracket, let y equals to x minus k. Therefore, in other words, sigma y is 520, sigma y square is 9640, value of n is 40. I'm not reading the question further. Let me go on my own way. Y bar is sigma y over n, that is 520 divided by 4, which is a simple number, which is 520 divided by 40. So that comes out to be 13. And let me calculate the variance for y. So the variance for y variable, that is sigma y square over n minus y bar square. So this is 9640. So this is 9640 divided by n, which is 40, minus 13 square. So therefore this comes out to be, after the simplification, this comes out to be 241 minus 13 square. So this is 241 minus 13 square, which is 169. This comes out to be the answer as 72. Now let me come back to this. The original data is for x. This is the original data. So first of all, for the second part, the rule is the variance of y is the same thing as the variance of x. So therefore, the variance of x, that value is also 72. It's unchanged by coding. It's unchanged by assume mean. But when we talk about the mean, so we have this equation y is equals to x minus k. Therefore, y bar is x bar minus k. Y bar is 13, x bar it's given as 34 minus k. So therefore k comes out to be 34 minus 13, which comes out to be 21. So the value of k comes out to be 21. So that's a straightforward question, just like that. Question number 3. It says for her bedtime, this person named Suki has either chocolate or tea or milk with probabilities such and such. So it's 0.45 and 0.35 and 0.2. When she has chocolate, the probability that she has biscuit is such and such. So let me first draw the 3 branches. So that there is a branch for chocolate, there is a branch for tea, and there is a branch for milk. So this is chocolate, tea and milk. So this is chocolate and tea and milk. And it's about eating biscuit, yes or no. So therefore, eating biscuit, yes is in green, yes is in green, yes is in green. And no is in, let me take this orange. So no is this orange and orange and orange. So therefore, this is about biscuits, and this is about not biscuits, and biscuit and no biscuit, and biscuit and no biscuit. So that is for this part. Let me change the color back to this orange, this reddish. The probabilities are 0.45, 0.35, 0.2. So 45% and 35% and 20%. Corresponding probabilities, when she has chocolate, probability of biscuit is 0.3. When she has tea, probability that she has a biscuit is 0.6. And Suki is strange. When she has milk, she never has a biscuit. So that is 0.0. So this is 1.0, this is 0.40, and this is 0.70. Find the probability that Suki has tea given that she does not have a biscuit. So I need 3 possibilities. Chocolate and no biscuit, that's 0.45 into 0.7. Let me just write it like this. It could be tea and no biscuit, that is 0.35 into 0.4. And the last one, that is M. What is M? M is milk and no biscuit. So therefore, this is 0.20 into 1.0. After given, what's written? Given that she does not have any biscuit, so Cn, Tn, Mn. So therefore, this denominator, that is Cn plus Tn plus Bn. Cn plus Tn plus Bn, that is the denominator, that's 0.45 into 0.7. And Tn is 0.35 into 0.4, 0.35 into 0.4. And last one, that is 0.20 into 1.0. And find the probability Suki has tea. So this person Suki has tea. So therefore this thing, these numbers, 0.35 into 0.40, that goes at the top. So now when you do this calculation, this comes out to be 0.14 at the top. So therefore this is 0.14, and the denominator after simplification is 0.655. So you can write this thing as 140 over 655. That looks nice. You can reduce it further. That is 28 over 131. Leave it as it is because fractions are beautiful. You don't have to worry about accuracy because fractions are exact. Next question. Now this time the question looks like a DRV, probability distribution question, and this is DRV. A fair spinner, so let me label this thing in blue. A fair spinner has edges numbered such and such, so there are 4 edges. Another fair spinner has edges numbered such and such. Each spinner spun, number comes to rest as noted. The random variable x is the sum of the two numbers of the two spinners. A very easy question. So therefore this is the first spinner, this is the second spinner. Put a plus sign over here, put 0, 1, 2, 2 over here, -1, 0 and 1, put it over here. -1 plus 0 is -1, and this is 0, and this is 1, and this is 1. 0 would make things remain as it is. 1 plus 0 is 1, and 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 2 is 3. So let me identify the numbers. So therefore -1 is occurring once, 0 is occurring twice, 1 is occurring 4 times, and 2 is occurring 3 times, and 3 is occurring 2 times. So double check. There are 12 possibilities, and these are the answers that you get, and we will make a table and we will leave the answer in the fractional form. So therefore this is the table, the probability distribution table. This was sample space diagram. You need a table. So making a table requires a sample space diagram. So this is -1, and this is 0, and this is 1, and this is 2, and this is 3. There are 2 values of 3, that's 2 over 12. And let me start with -1, that's 1 over 12. 0 is 2 over 12. 1 is 4 over 12, and 2 is 3 over 12. Let me double check. 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 3 is 10, 10 plus 2 is 12. 12 over 12 is the answer. No need to convert it into the decimal form. It's asking for variance. For variance we need to calculate expectation of x, that is sigma px. Let me just write down the working. -1 into 1, 0 into 2, 1 into 4, 2 into 3, 3 into 2 divided by 12, you will get some answer. Similarly, expectation of x square, that is sigma px square. So therefore -1 square into 1, and 0 square into 2, and this is 1 square into 4, and then it's 2 square into 3, and then 3 square into 2, everything added together divided by 12. And what is variance of x? That is expectation of x square minus square of expectation of x. You would evaluate, and then you get this answer. So 4 questions down, pretty straightforward paper till so far. Question number 5. Now it's about 2 friends, R and S, of a members of a quiz team which has 9 members in total. 2 photographs for the quiz team are to be taken. So it looks like a question of combination and permutation. Let's see. For the first photograph, what does it say? For the first photo, 9 members will stand in a line. How many different arrangements? So that is permutation for this part. 9 members are possible, in which Raman will be at the center of the line. So this person R is at the center of the line, and there are how many spaces left? There are spaces left 1, 2, 3, 4, and 1, 2, 3, 4, and 5, 6, 7, 8. Any one of the remaining 8 could occupy this space, or any one of the 7, any one of the 6, any one of the 5, any one of the 4, any one of the 3, any one of the 2, any one of the 1. I have deliberately written it like this because it's 8 factorial for the rest of them. So that's a simple working of 8 factorial for this one mark. How many different arrangements of the 9 members are possible in when R and S are not next to each other? That's another basic type of question. So this person is R and this person is S. So first calculate R and S. next to each other. So we are calculating next to each other. So therefore, how many are left? So the people who are left are 1, 2, 3, 4, 5, 6, 7. So this is 1, 2, 3, 4, 5, 6, 7, and this is 8. That is 8 factorial. What's happening inside the box? So inside the box, two options are there. It could be R, it could be S, it could be S, it could be R. I'm just drawing it because the paper is so easy, I feel like over explaining it. So this is basically 8 factorial multiplied by 2 factorial, that is together without any restriction, that is 9 factorial. Therefore, the answer is not next to each other. So not next to each other will be 9 factorial minus 8 factorial, 2 factorial. Of course, you can also do it by the space method, and that will also be a direct working. Now we are looking at the third part. What is the third part? The third part is, and there is a fourth part also. So now it says for the second photograph, the members will stand in 2 rows, 5 in the back, 4 in the front. 5 in the back and 4 in the front row. So let me make 2 rows. This is row 1 and the back is a little bit bigger, that's 5 places. So let me mark few places. So this is like 1 and 2 and 3 and 4. And over here this is 1 and this is 2 and this is 3 and this is 4 and this is 5. So row 1, row 2. How many different ways can the 9 members be divided into groups of 5 and a group of 4? Now, the first part, that is straightforward, part C. So when you separate 5 people, 4 are left, so that's 4C4. Or you could have separated 4 first and 5 are automatically separated. So this answer comes out to be 126 into 1, which is 126. That is the working for this one. Now it says for a random division into group of 5 and a group of 4, find the probability that Raman and Sanjay are in the same group as each other. So now let me carry this thing over here. So this is like this. It's not carrying the whole thing. So first of all, let me carry this on the side and let me carry this down. This is one possibility. And then it says Raman and Sanjay are in the same group as each other. So either this is the front row, this is the back row. So now either both are in the front, either R and S are in the front. So if they are seated, wherever they are seated, because it's like division into groups. If they are in the front row, therefore, out of the remaining 7, how many should be there? So all together there are 9 and a group of 4. A group of 4, that is the main thing. So out of 7, you have to select how many more? You have to select 2 more. So that is the first one, if they are in the first one. Or what is the other possibility? Or R and S are in the back row. This is the front row and they are in the back row. So therefore, if they are in the back row, this is R and S and same group as each other. Find the probability that Raman and Sanjay are in the same group as each other. So they will be there, and this time this would be 7C3. So the first option is in the front, R and S, and the other people are also there, and R and S are in the back row, and it's a 5-seater, So that is why this is 7C3. So it's either or, that means you have to add it up. So 7C3 plus 7C2, so these two adds up and it comes out to be 21 plus 35, which comes out to be 56. And without any restriction, that is basically answer of part C, or you can say that groups of 5 and 4, that is answer of part C, that is 126. So therefore they're asking for the probability is 56 over 126. So that is the working for this particular question, which was question number 5. Question number 6, what is this all about? It looks like it's a back-to-back stem plot. So it's a stem plot, and there is also a box plot on the next page. Let's have a look. And it's about some comparison. So I mean, it's just a basic stuff. Now it says the weights of 15 rugby players in the Rebels Club and 15 in the Sharks Club are as shown below. Represent the data by drawing back-to-back stem and leaf diagram with Rebels on the left hand. Now the lowest value of Rebels that you can see, let me mark it. So that is somewhere over here. It's already arranged in ascending order. So the lowest value of Rebels is 75, highest value is 102. For Sharks, it's 66 and it's 92. So that's a good thing that they have already arranged it. So when they have already arranged it, let me do one more thing. And that is, let me make groups right out of it. So over here, there is the group of 75, 78, 79. That's the first group. 80, 82, 82, 83, 84, 85, 86, 89. That is the second group. And then in 90s, you have this thing, 93, 95, 99. And 102 would be in the other group. Similarly, over here, the 70s group and the 80s group, and this one is the 90s group. This one is the 102 group, and the first one is the orange one is the 60s group. So now that's how you can label it. So it's done very neatly by the examiner and by me also, so that everything is set. So draw lines like this. 1, 2, 3, 4, 5, and 6. Maybe 6 lines are needed. And then draw vertical stem in the middle. And it says Rebels on the left. So write Rebels on the left. And what's on the right? That is Sharks. The value is 6, and then 7, and then 8, and then 9, and then 10. For the Rebels, you're gonna start labeling. There is nothing with the 6, so that would be blank. With 7, it's 5, 8, and 9. So this is 5, 8, and 9, and write 3 at the corner. With the 8, this is 0, 2, 2, 3, 4, 5, 0, 2, 2, 3, 4, 5, and 6 and 9. 6 and 9. And how many are there? It's 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 of them. Let me just push it a bit over here so that things are streamlined. It's too much space out. Okay. Now it looks better. This is 8. And then with 9, it's 3, 5, 3. That's 3 of them. And for 10, it's 1, 0, 2. So this is 2 and this is 1. So 3 plus 1, 4. 4 plus 8, 12. 12 plus 3, 15. Double check. This is 15. Now let's start labeling for the Sharks. This is 6 and 8. So this is 6. This is 8. That's 2 of them. And then for 71, 72, this is 1, 2, 4, 5, 5, 6, 8. 1, 2, 4, 5, 5, 6, 8. This is 7 of them. Next one, 3, 3, 4, 5, 6. 3, 3, 4, 5, and 6. That's 5 of them. Next one is 92. This is 1. 5 plus 1, 6. 6 plus 7, 13. 13 plus 2 is 15. Okay, so now this thing is done. What do I need? I should give a key. So my habit is giving two separate keys for each one. For example, 5/7 means 75 kg. And over here, 9/2 means 92 kg. So that's kg. These are the weights. Find the median and interquartile range for the rebels. So median, 15 divided by 2, that is 7.5, rounded up, that is the 8th value. Let me draw it comfortably. This is the 8th value. There are 7 lower values and 7 higher values. Now let me change the color from blue to orange, like this. From the 7 lower values, first of all, mark the median. That's the 8th value, and the median, I'll mark it in green. So this is the median value. So for rebels, it's 1, 2, 3, 4, 5, 6, 7, 8. So 84, 4/8 is 84. So Q2 is 84. That's the first thing. Then what are we looking for? From the 7 lower values, you're working as 7 divided by 2 is 3.5, rounded up, that's the 4th value. And the same goes for here. So from these orange values, this is 1 and 2 and 3 and 4 and 5 and 6 and 7. The 4th value is what I'm looking for. So 0/8 is 80. So the lower quartile is 80. So Q1 comes out to be 80. From the bigger 7 values, let me choose this thing. That is 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3 and 4. This one, 3/9 is 93. So therefore, the Q3 comes out to be 93. And hence the interquartile range is upper quartile minus lower quartile. That is 93 minus 80, which comes out to be 30. So this is the working for this particular part. Now it says a box plot for the sharks is as shown. We have to draw a box plot for the median. What is the lowest value for the rebels? We have to draw it for the rebels. Sharks is drawn. We have to draw for rebels. The lowest value is 75. So first of all, mark 75. That is the lowest value. So this is 75 somewhere here. And I'll just mark a dot. And then I'll just draw it of the same width as before. Then we have median, which is 84. And then a lower quartile is how much? Lower quartile is 80. So after 75, this is 80. After 80 is the median, which is 84. Then we have the upper quartile, which is 93. And last but not the least, that is the highest value. Highest value is 102. Highest value is 102. Now, first of all, draw a box. So the box would be, let me draw it in purple like this. 2 with upper, 2 with down. So somewhere like this. This is thicker. Let me make it thinner. Like this, and like this. I'm drawing it very, very accurately. That's a box. That's a box. And then I'm drawing a whisker to the right. And I'm drawing a whisker to the left. So this is for the rebels. REBELS. So that's how this thing is drawn. And then of course you can draw it like this. Dark line and then a dark line to show the endpoints. This thing is done for 2 marks. Make one comparison between the weights of the player in the Rebels Club and the weights of the player in the Sharks Club. Now they both look like positively skewed, so that cannot be a comparison. Interquartile range more or less looks the same. So I'll just focus on the median. The median of rebels is higher than that of sharks. So I would say on average, the rebel players are heavier than sharks player. So when I use this term on average, this means that I have used the concept of median. So that's how this thing is done. Now we are finally reaching the last question. That last question looks like normal distribution. So that is this one. The question says the time in minutes that Carly spends each day on social media is normally distributed such and such. X follows a normal distribution 125, 24 square. On how many days of the year would you expect? This is the keyword, that is expect. And 365 is the total. That means you have to calculate expectation. But first, the probability. Probability X is greater than 142. Probability Z is greater than 142 minus 125 divided by 24. So when you do the reduction, the simplification, this is probability Z is greater than 0.7083. Z is greater than 0.7083, which is 1 minus phi of 0.7083. Go to the table, read of the value, subtract. So this is 1 minus 0.7604, which is 0.2396. Do not round off over here, leave it as it is. Expectation is NP, because basically what is happening is that X follows a binomial distribution. 365, answer of this, that is 0.2396. So we are calculating expectation. That is 365 multiplied by 0.2396. Use a calculator. This comes out to be 87.454. So therefore both answers are acceptable. Either you write this thing as 87, that is acceptable. You write this answer as 88, that is acceptable, because it has to be on how many days? So it has to be an integer. So being an integer, that is a must in this particular part. Next question. Find the probability that Carly spends more than 152 minutes on social media on fewer than 2 out of 10 randomly chosen days. So this statement, more than 142 minutes, is what you just calculated. This probability is 0.2396. And on fewer than 2 out of 10 randomly chosen days. Y follows a binomial distribution 10, 0.2396. Probability Y is lesser than 2. Probability Y is lesser than or equal to 1, which is 10C0. This particular term, so let me write more space, 10C0 and 10C1. Basic addition. So this is 0.2396. This is 0.2396. And you already had that value up at the top. That was 7604. So this is your failure, 7604, 7604. Power of 2396 is 0 and 1. Power is 10 and 9. You add up both the probabilities, and this comes out to be 0.268, correct to 3 significant figures. Now let's move to the third part, and that looks like the last part to me. On 90 days, let me first write the distribution. X follows a normal distribution. How much is the distribution? That is 125 and 24 square. So this is 125, 24 square. The question says on 90%, Carly spends more than 90 minutes on social media. Probability X greater than T is 90%. Probability Z is greater than T minus 125 over 24 is equals to 90%. Probability Z is greater than some value is 90%. Because of this greater sign, there is a negative, and this value is 1.282, a very famous value which I can show you. There it is, 90 is 1.282. So therefore, this comes out to be t minus 125 over 24 is negative 1.282. T minus 125 is negative 1.282 multiplied by 24, and hence you can find the value of t, which will come out to be lesser than 125 because the z value is negative. That comes out to be 94.2. So that's how this paper is done, and this is November 2021 S1 paper, and this is variant 55. Stay tuned for more.